Now that we know what an angle is, let's talk about measuring and classifying them. Two really quick definitions. The interior of an angle is the region containing all the points between the two sides of the angle. So that would be this green area right here. And the exterior of the angle is everything else that's not the angle, the stuff outside of it. So that would be this yellow region here, which leads us to the protractor postulate, which allows us to measure angles. It says that every ray that shares an endpoint with a given ray, in other words, for both of the rays on an angle, they can be paired with a real number. This makes a one-to-one correspondence between the rays creating the angles and the real numbers. Sound familiar? Kind of like the ruler postulate. It makes a little bit more sense with a protractor. And again, the wonders of technology. You will see at point A that there are a couple of numbers here, 140 and 40. And at C, there are a couple of numbers here, 150 and 30. You would only use one set of those numbers, either the inside or outside, but there is a one-to-one correspondence to each of the rays. Which leads us to the definition of the measure of an angle. It is the absolute value of the difference of the real numbers paired with the two rays on the protractor. Notice how it's denoted with the M in front of the angle measure. So the measure of angle A, B, C is the absolute value of the difference of the two numbers. Now here's the tricky thing. With the numbers, you choose either the inside or the outside. So I'm going to choose the outside in this case. That's 140 degrees minus 30 degrees. And again, it doesn't matter whether you choose the inside or outside, so long as you are consistent. So if we do our arithmetic now, 140 minus 30 is 110 degrees, and the absolute value of a positive 110 is still a positive 110. And the units for angles is degrees. Now that we know how to measure angles, we can classify them according to their measures. This is what most of my students know already. An acute angle is an angle whose measure is between 0 and 90 degrees. So it has to be more than 0 and less than 90 degrees. A right angle is an angle whose measure is exactly 90 degrees. In a figure, you will know if they are right angles or not, because they will have this red box. This red box at the vertex is what tells you it is a right angle. Obtuse angles are angles that have a measure that is greater than 90 degrees, but less than 180 degrees. Our final angle classification is a straight angle. A straight angle is an angle whose measure is exactly 180 degrees. In other words, it forms a straight line. So let's give this a try. What are the measures of angle LKN and angle JKN? Well, let's go ahead and look at these angles individually. Angle LKN, let's trace it from point L to point K over to point N. Let's look at its measure. The measure of angle LKN is going to equal the absolute value of the difference of the coordinates. Let's see here. If I look at the outside numbers, the number associated with ray KN is 0 degrees, and the number associated with ray KL is 145 degrees. It's halfway between 140 and 150. The difference of 0 and 145 is negative 145 degrees, which then is 145 degrees. The whole purpose of the absolute value is to make sure that we never have a negative angle measure, just like we never have a negative distance. Because the measure of angle LKN is between 90 and 180, angle LKN is obtuse. Alright, so now let's take a look at angle JKN here. The measure of angle JKN is going to equal the difference between, shall we use the inside numbers this time? 180 degrees minus, in this case, notice that up here at the top, 90 is the same whether you're inside or outside. So that is going to give us 90 degrees. 180 minus 90 is positive 90, and the absolute value of positive 90 is 90 degrees. And so since the measure of angle JKN is exactly 90 degrees, that makes angle JKN a right angle.